So we're going to review the density lab. All right, now, first thing, let's talk. If we have these 3 pieces of metal, right, and all of these weigh the same thing, which one of these would be the most dense? Which one of these would have the highest density? What do you think, Maisie? Huh? It would be the most dense, would have the most material packed into the smallest place. Yeah. So this one's the most dense, right? This one would be the least dense, and this one would be right in the middle. Does that make sense, everybody? All right, cool. So that is density. Now, you kids that are in this room, you probably already know which one this one is. Davis, which one's this? Yeah, and one of the ways we could tell is if you looked at your tables right now, you would see that aluminum has the lowest density on the table. So if we glance at our tables, you can see that out of the metals, aluminum is the least dense. Density is 2.7 grams per cubic centimeter. It's at the top. All right, I take that back. Lila's making me look bad, everybody at home. It's actually magnesium, she pointed out. But magnesium's not one of these. So this one right here on the right, this is aluminum. So aluminum is the least dense. This is zinc. It's about in the middle. And then the most dense one we have is the smallest, that'd be copper. Because in reality, all 3 of these weigh the same. They all weigh about 70 grams. So we're going to calculate the density of this aluminum right here. And I'm choosing aluminum because it's the easiest one. It's the easiest one for us to measure because of its size. I'll show you why. So the formula to calculate density is D equal M over V, or density is equal to mass divided by volume. So the first thing we're going to calculate right here is mass. I'm going to take this scale, I'm going to turn it on. Hopefully this one's not battery dead. All right. We got 0. Boom. Going to put that bad boy on there. And this one weighs 71.65 grams. Okay. 71.65 grams. So right here for mass, I'm just going to write 71.7 grams. Now we need to figure out the volume. All right. The volume is we're going to measure the volume here using displacement with water. All right, so I just put some water in here. I just put some water, no specific amount. Okay? And if we read, I don't know if you can see it at home, but I'm going to read the side of this, and I'm going to tell you that the water level is right between 47 and 48. So I'm going to call this 47.5 milliliters, all right? So I'm going to write down, I'm going to make a note to myself that there's 47.5 milliliters in here. Then I'm going to put the aluminum in. Okay. So put the aluminum in, and it went up to It went up to 73 milliliters, maybe just a little bit below that. So it went from, at first, it was 47.5 milliliters. And now I'm going to say it's just below 73. I'm going to call it 72.8 milliliters. So the difference between these two numbers, if we subtract them, that's how much the water went up. So 25.3 milliliters, that is the size of the aluminum. So, in other words, when we put this chunk of aluminum into the water went up 25.3 milliliters. The process of using water to measure how large something is called displacement. when you put the object into the cylinder, it displaces the water. Right? Now, real simply, here is our formula. Density is equal to mass divided by volume. 71.7 divided by 25.3. So if we say density is equal to 71.7 divided by, that's grams, divided by 25.3 milliliters, the density of this is? 2.8. We get 2.8. And if you look on the chart, the official chemistry chart for aluminum, you get 2.7. So that is density, and that's how you calculate it.